Bismillahirrahmanirrahim. We talked about this before. A concept called direct variation. Okay, today we're going to talk about inverse variation. Basically, very similar process. If I told you, when two variables are related directly, remember it was like this, y equals ax. Do you remember that vaguely? So when two variables are directly related, they're like this. Okay? That means an example would be like, okay, somebody has a job, okay, and their pay, okay, is $10 an hour, okay? Okay? And so their total income is going to be their pay times the number of hours they work. H being the hours, right? Do you understand? So this is a direct variation. Yes or no? So anytime two variables are related like this, okay, that's called direct variation. And this constant number, the pay is constant, right? The number of hours changes, and the number of income changes based on the hours, right? You follow? But this constant term, that's called constant of variation. Do you understand? So for example, I just tell you, okay, you know what? I don't know how much he gets paid, this dude, okay? But then, he only worked 7 hours and he made like, $4,500. Okay? So he worked for 7 hours and he made, income was $4,500. I don't know, maybe we have to figure it. That's a boatload of money, man. They hate that. What would they do? It's like, yeah? Maybe they do a surgeon or something. Okay? Do you understand? So then you say, okay, what's their hourly rate, right? You want to know what their pay is, right? You're curious, right? But this is a direct variation or no? Okay, so the equation is going to look like y equals ax, right? In this case, it's like income equals their pay times the hours, right? Correct? Now we're told we don't know how much they get paid per hour, right? Do we? All we know is that if they work 7 hours, they get $4,500, right? Do you understand? So, well, in this case, we don't know the constant of variation. Does that make sense? But we're given one values. Now, if I said, okay, if they work for, 5 hours, if they work for 5 hours, they get like, $3,000. That's another pair, right? Do you understand what I'm saying? So if you know one pair of data, in other words, if you know one pair of data, then you can figure out the constant of variation. Does that make sense? Okay. So let's figure out how much this dude makes per hour, right? Shall we? So their income is $4,500 equals. Now what we really want to know is if they work like a 40-hour week, how much are they going to get paid, right? That's what we want to know. How much is the income going to be if they work for 40-hour week? That's what we want to know. Okay, now, so income is this, and their pay we don't know, and they work for 7 hours. Now we can find out their pay, right? What is that? What's 45 divided by 7? Hmm? 6.42, 642?
Yeah.
642?
Yeah.
Point?
85 or 86.
Let's just call it. Wait, the guy's pretty rich. Let's just run it to 643, right? He gets that much per hour, right? Yes? Ho, ho, ho. Okay? That's the constant of variation. So we can write the equation y equals 643x, where x is the hours where he works and y is the income. Income equals 643 hours, correct? Now we know that we can figure out how much money he makes depending on what hours. Now let's see how much money if he were to work 40 hours. So we say y equals 643 times 40. Okay, what is it?
25,000.
How much?
25,720.
That's pretty good. That's just 1 week. I wonder what they do. You understand? Business, man. Okay? So, now what did we do over here? In this case, if you're given, now in this case, you're given the constant of variation, right? You're given that, right? But if you didn't know, and if you were told that it's a direct variation, the equation is going to look like this. And if you're given one set of values over here, you can figure out the constant of variation. Does that make sense? Yes? All right. Now, let me ask you this. Is this a direct variation? I don't know. I don't know. But if it was, okay, you would have to follow this rule, right? Correct? Okay, so let's figure out. Let's pick just any bit of data and plug it in, figure out what A is. Fair? Okay, Y is 3 when X is 1. So A is 3. That was easy. Right? Okay, now we know what the constant of variation. Now we can write the equation for the direct variation, which would be y equals 3x, if this is a direct variation. Right? And we use this piece of data. Now, if this is true, this should apply to every single piece of data. Yes? Okay. So, when x is 2, y should be what? Is it 6? No. When x is 3, it should be what? Is it 4? No. So this is not a direct variation. You know what this is? No. It's a linear relation. It's like y equals mx plus b. Okay? So it's actually y equals 2x plus 1. I think. Yes? Okay? Now look. So, now this is a direct variation, right? Yes or no? Is this a direct variation? No, by definition, no. Direct variation has to look like that. Does that make sense? Now, we did this before. The same concept can be applied to this. Y equals 1, A over X. This is inverse variation. Do you understand? You follow? Okay. Because why are we talking about this? Because X is in the denominator. It's like a rational equation, right? It's like this. Okay? Okay? So watch. Y equals 3 over X, inverse variation or no? Yes. Anytime two variables are related like this, okay, it's an inverse variation. Got it? How about this? Inverse variation? No. 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 Do you understand? Only this. Very simple. Okay? So now, okay, let's do this. You wouldn't have to tell me if this is inverse variation or not. And if it is, you're going to have to tell us what's the constant of variation. Okay? Ready? We have to figure out, the question is this an inverse variation? Okay? And if it's an inverse variation, what is the constant of variation? Okay? Now, if it was an inverse variation, what would this look like? Y equals A over X. And A is called what? What's the constant of variation? All right. Well, we don't know what it is, right? Well, let's pick a value and let's figure this out. Okay? So when y is 3, x is 1, right? So a is what? A is 3. Oh, good. That was easy. So now if this was the inverse variation, then the equation would be y equals 3 over x, right? This is the equation for the inverse variation if these set of data was inverse variation. Okay, let's check it out. So we used this to figure this out. Okay, when x is 2, what should y be? When x is 2, y would be? Is it 3 over 2? Oh, it works out, doesn't it? Okay, when x is 3, if you plug in 3, y should be what? If it is direct variation, huh? 1. Is it 1? You bet it is. When x is 4, what should y be?
3 over 4.
Is it 3 over 4? So this is an inverse variation. Okay? Okay, and the equation for the relation is this. Does that make sense? This is inverse variation. So this, if two variables are related like this, that's called a direct variation. And if two variables are related like this, that's called the inverse variation. Okay, if two variables are related like this, what is this called? It's a linear relationship. Did you understand? That's that y equals mx plus b. That's a linear relationship. Does that make sense? Okay, that's it for this one.